Number 19, we want to write this expression in standard form. And what we need to do with this problem is rationalize the denominator. So they don't say it, but you do need to understand when you see a problem of this type with an imaginary on the bottom or square root on the bottom, we have to rationalize the denominator. So we have, 5 minus 4i on the bottom. So we don't like square roots, and I comes from the square root of -1, so we have to get rid of that. The way we do that is by multiplying by the complex conjugate, which is basically this term, change a plus in the middle. It's kind of like the difference of squares. So 5 plus 4i. Whatever you do to the top, you do to the bottom. 5 plus 4i. And so on the bottom, I'm going to apply difference of squares. Okay, and so it's going to be 5 squared, which is 25. And then 4i squared minus 4i squared, that's going to be 16i squared. Okay, that I squared is going to turn to -1, and we will no longer have imaginary on the bottom. That's the whole goal. And then we also have to simplify the numerator while we do that. So 7 times 5 will give us 35. 7 times 4i will give us a positive 28i. 22i times 5, 10, 10. So to give us 110, negative 110i. And then 22i times 4i, and it's negative, so it's going to give us a negative 88i squared. All right, now we're going to start reducing, okay? So I'm going to just wrap around and start back over, going left to right. On the top, I'm going to write 35. Now, I squared is -1, so if I multiply this times a -1, it's going to change to positive 88. So I'm going to write plus 88, combining my like terms. These are already like terms, so different signs we will subtract. So take away 20 to give us -90, and then 8 that'll give us a -82, -82i. And then on the bottom, I'm going to convert this to a -1. -1 times a negative give us a positive. So we have 25 plus 16. Then we're going to combine these two, 35 and 88. 110, 123. So we get 123 on the top minus 82i. And then on the bottom, this is going to give us 41. And if we can reduce, we're going to do that. So to put it in a plus bi form, we're going to divide both of these by 41 separately. So that's going to be 123 over 41, and then minus 82i over 41. And I think both of these are divisible by 43. So divide by 41. They're both divisible by 41. Divide by 41, and that's going to give us 3. Divide by 41 is going to give us a minus 2i. So 3 minus 2i. That will match up with D. Number 20. Okay, so this is one that we have not seen. So let me give you a little background. Traditionally, when we've been doing absolute value problems, so this is just some notes for number 20. When we do absolute value, let's say we have the absolute value of some expression x, and then it is greater than, or let's just say equal to. Absolute value of x is equal to, let's say, positive 2. Okay, let's just say 2. We can solve that. And then when we have absolute value of x, and let's say that it's equal to -2, we cannot solve it because absolute value cannot equal to a negative, therefore no solution right here. All right, now we can also look at a couple scenarios with greater than and less than. So let's say we had the absolute value of x is greater than some negative number, for example. And then we could also do this absolute value of x is less than some negative number. These are the special cases. When you do the absolute value, it changes positive. So a positive number is always going to be greater than a negative number. In this example, your solution will be all real numbers. And you don't even have to solve it. This is true 100% of the time, because a positive is always greater than a negative. And that's what happens with absolute value. Now, on the flip side, when you're dealing with less than, absolute value of a number is always positive. Positive number is never going to be less than a negative. So this will not happen ever. And if you see this set up, then there is no solution. So we're going to be dealing with one of these scenarios here. So I need to point them out. They're a little bit different than just equal when it comes to negative. So when we had equal to, there was no solution. But in this case, there could be a solution, or there may not be a solution, depending on the direction of your inequality symbol. So number 20, we have absolute value of 2x minus 7 and then plus 5 is greater than 3. So let me just help a little bit and drive this point home. I'm going to put a couple different numbers here and just show you that this is going to be a true statement 100% of the time. It's kind of hard seeing it with variables. Let's say that I had a negative 100, absolute value of negative 100. I want to know, is that greater than negative 2? Well, absolute value of 100, absolute value of negative 100 is 100. So we get 100 is greater than negative 2, and that is true. Doesn't matter what I put here. If I put 1/2, okay, absolute value of 1/2 greater than negative 2. Absolute value of 1/2 is just 1/2. Okay, running out of room down there. And 1/2 is greater than negative 2. So this side is always going to come out positive. Positive is always bigger than negative. If you think about the number line, negative on the left, positive on the right. No matter what number you plug in here, whatever you get, whatever it simplifies to, it's going to get turned into positive. It will be true. So you will always have this. So if you see, once you isolate your absolute value, that this is scenario, all real. If this is scenario, no solution. Okay, so here we have this. We got to simplify or isolate our absolute value expression. And so we're going to subtract 5 from both sides. Okay, so then I have absolute value of 2x minus 7. And then that goes away to 0. That cancels out. Is greater than negative 2. Okay, so look, we have absolute value isolated, greater than negative. Doesn't matter what this comes out to be. You don't have to solve it. You don't have to do that. Two sides is just extra work. But once you see that this scenario happens, when you have a negative, it's only when you have a negative. Once you see that when this scenario happens, then you don't have to solve it. You can just go and put the answer. This is going to be negative infinity to positive infinity. Okay, that's it. Any number that you plug in will work. Say, for example, if I plugged in a 10, 2 times 10 minus 7 greater than negative 2. That's 20 minus 7 is 13. Absolute value of 13 is greater than negative 2. And even if I plug the negative 10, that'd be a negative 20, that'd be a negative 27, and when you absolute value, it'd be a positive 27. So whatever comes in here changes positive, and it's always going to be bigger than the negative. So it's going to be all real numbers, no matter what you use. Sorry, I didn't realize I cut off that 13 down there. Okay, so all real numbers here.